According to the globe model, sunrise and sunset are the result of Earth rotating at a constant rate, and always at approximately the same distance from the Sun. This means the Sun's angular size never gets bigger or smaller except by about 3% throughout the year, and its angular path through the sky never slows or quickens except by 8%. In stark contrast, flat earthers say that sunrise and sunset are the result of linear perspective as the sun travels horizontally overhead. What would that look like? It's very obvious flat earthers don't really know, because they don't really understand linear perspective. The term vanishing point can be deceiving. What it actually means is the point where parallel lines appear to converge at infinite distance. Yes, infinite. If an object travels along these converging parallel lines, it's impossible for it to actually reach the vanishing point until it's smaller than the grains and flaws of the image. For the sun to set by reaching the vanishing point, it would have to keep receding long after it looked smaller than a star, and its movement toward the horizon would get slower in the same way, practically coming to a stop before it disappeared. Now, one flat earther I've seen combats this by speculating about something he calls atmospheric magnification, the idea that humidity in the atmosphere, or microscopic water droplets, are magnifying the image of the sun as it sets. He demonstrates this in a very superficial way using a plastic Fresnel lens on a dining room table, and as evidence he offers a misconstrued quote from an expert.
So the atmosphere really is acting like a lens.
Yes.
And a false measurement of a skyline.
This building is significantly magnified.
But supposing there was a fantastical barometric lens to accomplish this, there is still no way it could reproduce his illusion for observers at more than one location at a time. We know that at some basic level, sunrise and sunset look the same for all observers in all locations. This means that roughly speaking, any optical distortion from the atmosphere must be horizontally homogeneous. In order to magnify an image, rays of light must be converged toward a focal point, which is by definition a heterogeneous operation. Light falling on one side is turned one way, light on the other side is turned the other way. It would therefore be impossible to design or build an optical system that magnified images in all directions the same way for observers in all locations at once. If the sun were ever magnified like this, mankind would have to know more than one kind of sunset, the normal kind as seen from the normal angle, and at least one other completely alien kind, probably dozens, as seen from all other angles. But this is not so, and thank goodness, because any poor soul standing in the path of convergence would burn to death, exactly like a bug under a magnifying glass. And even from the right location, the illusion would be incomplete. According to linear perspective, the size and speed of a flat Earth sun would change all day, not just at twilight. Let's take a closer look at the geometry. From this diagram, we can see that the angle of a flat Earth sun would change according to an inverse tangent function, not a linear function like a globe model sun. Every tutorial on linear perspective accounts for this, and most of us are familiar with seeing it when a car passes on the road. With a good working compass and sextant, the difference should be easy to spot anywhere in the sky, or if you want to save money, a protractor and plumb line are a low-quality substitute for the sextant. These instruments are necessary because for angular measurements, we don't want to rely on pixels in a photograph. Photography brings variables into the equation from both lens and image projection, not all of which we can precisely calculate. In this debate, we all know what a sore spot fisheye distortion is. A quick note. Both compass and sextant are necessary to truly show the sun's constant speed, unless of course you measure from the equator on the spring or autumn equinox. The sextant will show the sun's altitude and the compass its azimuth, which are the components of its two-dimensional motion vector. To find scalar speed, these two readings will need to be combined using spherical trigonometry, in this case for the shape of the sky, not the Earth. But to settle the debate, that much precision isn't necessary. The speed of the sextant alone should stay roughly constant, not dramatically slow down as the flat Earth predicts. For size, a practical consideration is brightness. Flat Earthers use footage like this to say the sun gets larger and smaller from our point of view. But there's obvious glare totally nuking the actual edge of the sun and spreading into other parts of the image. And considering the sun is bright enough to burn your eyes out, there's no telling how far. No photograph of the sun can show its true size unless it's exposed low enough to show a solid edge. That is why we need welding glass, to act as a lens filter for our camera. What happens if we show... Oh, you can barely see my fluorescent light there. For my experiment, I have 4 cameras. 2 I set up with a typical view of the sunset, as nearly the same as I could. 1 filtered with welding glass, and 1 without for comparison. Nearby, I have the compass and sextant on a level spinning table. A 3rd camera shows the view through the sextant, which I will adjust to follow the sun, while a 4th shows the readings on both instruments. Use the 0 on the vernier scale to read the sextant. All footage is synchronized to a common reference both before and after, so we can watch everything at once. Ready? Straight away we see what a false impression flat earthers give of the sun changing size. You could see that in your own experiment with nothing but the welding glass, just like many people do for fun when they look at a solar eclipse. And notice something else. If we overlay frames from the time-lapse at constant intervals, we see not only constant size, but also constant speed. This is plain to our eyes, and all the fuss with the compass and sextant was just to verify it numerically. Both readings are as straight as an arrow, especially the sextant owing to its higher precision. The scalar speed calculated from these two definitely shows some noise, but even so stays fairly close to constant. This number would be more important when measuring closer to midday when the sextant reverses direction. Honestly, I can't imagine how these results could be any more conclusive. The sun clearly goes below eye level, which forces us into that ancient dilemma. Either the whole world experiences sunset at the same time because the sun travels underneath it, or the definition of eye level is relative, because it's a sphere. If you know anybody across the Atlantic or Pacific Oceans from your location, Skype or FaceTime them. Ask them where the sun is and compare it with your own location. This is not a conspiracy. Try my experiment yourself. Seriously.